Hi there, welcome back. This is Weblan. I want us to look at this scenario. We are looking at grade 10 trigonometry, and we want to make use of some trigonometric ratios here. And I also see somewhere where we are going to use Euclidean geometry. But before we answer the questions here, let me remind you to like and subscribe. All right. In this scenario, we are told about a jet which is flying from your left coming to the right. And this jet in this particular moment is at point J, which is vertically above D. So we are saying the altitude of this jet is 5 kilometers. And remember, altitude is height. So the height dj is 5 kilometers, and from point J, the angle of depression is 8 degrees. Angle of depression, we are talking about the line of vision here. We are saying you are at J and you are looking at K. If you are looking at K, we have the angle that is made with your line of vision together with the horizontal line. We call it the angle of depression. And then we also have what is called angle of elevation. When we talk about angle of elevation, we're assuming that you are standing right here at K. And if you are standing at K, looking at J, this is your line of vision. So angle of elevation will be this angle, which is made with your line of vision together with the horizontal line. And you should always remember that the angle of depression is always alternate to the angle of elevation. Depression, elevation. Because this horizontal line is always parallel to this horizontal line. That makes these two angles equal because they are alternate, right? So the first question here is determine the size of angle K. From what we have just discussed, K is equal to 8 degrees alternate angles. That is from Euclidean geometry. And then from there, we want to determine the size of side dk. That is the horizontal distance from point D to point K. If we have an aeroplane that is at that point, how many kilometers do we have from D to K? We have triangle DKJ here. Triangle DKJ. So we use that triangle DKJ. In this triangle DKJ, we have seen that this angle is 8 degrees alternate angles. Remember, whenever you get new information, you need to add it to the diagram. That's going to help you to see things clearer. Now, in our triangle, we have the angle given here, and then we are looking for dk, which happens to be adjacent to the angle. And we are also given this angle, which happens to be opposite to this angle. So we have adjacent, we have opposite. Which ratio do we use? A ratio which has opposite and adjacent. That is tan. So we are saying here tan 8 is equal to opposite over adjacent. That is equal to dj over dk, and we are looking for dk. We are already given dj. So tan 8 is equal to dj is 8 kilometers over dk. We are looking for dk, so we need to take it to the left. When you take it to the left, it is dividing, it goes to multiply there. dk times tan 8 is equal to 8, sorry, this is not 8 kilometers, ne? This is 5 kilometers. That was a mistake. So dk, so tan 8 is opposite of adjacent, which is equal to dj over dk. We are given dj there as 5 kilometers, and we are looking for dk. So your tan 8 is equal to 5 over dk. Your dk is dividing, it goes to multiply on the other side. Now our tan 8 goes to the right because we have to isolate this dk. So dk is equal to 5 over tan 8. 5 over tan 8 there, it gives us 35,58 kilometers. So the distance between point D and point K is 35,58 kilometers. Remember, you are supposed to always have your calculator when you are doing your maths. Ne? That is the first question, or the second one. Now we want ds. How long is ds? It is given that sk, it is given that sk is equal to 8 kilometers, right? If we are told that sk is 8 kilometers, how big is ds? If this is given to be 8 kilometers, ds will be equal to what? From the diagram, we can see that ds plus sk is equal to dk, and our sk is given, it goes to the other side, so ds is equal to dk minus sk, which is equal to, our dk is equal to 35,58 minus sk is equal to 8, and this is going to give you 27,58 kilometers. So ds is 27,58 kilometers. And then the last part of our question, we need to determine the size of JSD, the size of angle JSD, that is this angle. So we can make use of triangle JSD, and in triangle JSD we saw that ds is equal to 27,58 kilometers, right? This ds is 27,58, and then our altitude is 5 kilometers. So in that triangle, we can see that we've got adjacent, we have opposite. So we use tan also. So this is going to be tan S, let me just say angle S here, is equal to opposite over adjacent, which is equal to 5 over 27,58. So our tan S is equal to 5 over 27,58. And then to get angle S, that is going to be the second function of tan. The second function of tan, 5 over 27,58. And this gives us 10,28 degrees. So JSD is 10,28 degrees, right? So we have seen that our K using alternate angles, it is 8 degrees, and then DK, that is the horizontal distance from D to K, is 35,58 kilometers, and then SD, we calculated SD given that SK is equal to 8 kilometers. So our SD or DS, we saw that is 27,58 by subtracting 8 from 35,58 kilometers. And then the last part was to determine angle S in this triangle JSD, where we are given the opposite and the adjacent. So we used tan S, which is equal to opposite over adjacent, and S will be the second function of tan 5 over 27,8, which is equal to this one. That's how we deal with our trigonometry. Remember, practice makes perfect.